All right, discrete math. Well, we are on our last section of chapter two. We're talking about the mathematics of power. We are going to digress a little bit from power to focus a little bit more on the mathematics behind what are called subsets and permutations, which are some things that we've been talking about in this chapter. We just have not had a formal name for some of these. So we're going to talk a little bit more kind of pure math and a little bit less application based stuff to wrap up chapter two. So, coalitions are essentially sets of players that join forces to vote on a motion. That's what we've been talking about for the last couple of sections. This is the reason that we use set notation in section 2.2 to work with coalitions. By definition, a subset is of a set is any combination of elements from the set. This includes the set with nothing in it, which we call the empty set, and it's denoted a couple ways using set notation. You can see one of those here with the brackets with nothing in them. You can also see the empty set written as kind of a zero or an O with a slash through it. It's also sometimes referred to as the null set. So those are all kind of describing the same thing. Also, subsets can include the set which has all the elements, which is really just the same as the original set itself. So let's talk some examples here. So subsets of P123 and P1234. So the following table on the next slide is going to show the 8 subsets of P123. And again, there are 3 players, so the 8 is coming from the fact that we are able to choose 3, and then so on. And then the 16 subsets of P1, 2, 3, and 4. So your subsets and where those are coming from are based on the number that are in the thing. So basically the formula for these, in case you're wondering, that 8 subsets is coming from 2 to the power of 3. The 16 is coming from 2 to the power of 4. So if you take 2 to the power of however many players there are in, that will tell you the number of subsets. I think I've got this written as a formula for you later on. So the subsets P1, 2, 3, and 4 are organized in 2 groups. There are the no P4 groups and then the add P4 groups. The subsets in the no P4 group are exactly the 8 subsets of P1, 2, 3. The subsets of the add P4 group are obtained by adding P4 to each of the 8 subsets of P1, 2, and 3. So here those are probably a little bit easier to look at now. So you've got on the left side your subsets of P1, 2, 3. So you've got all those listed there for you. And then when you go to P1, 2, 3, 4, all they're going to do is, here's the list of all of them that have no P4. So if you notice, none of these have P4, so they're all still subsets of P1, 2, 3, 4. And then to get the remaining 8, you just add P4 to each of those groups. So the key observation is that by adding more and more elements to a set, we essentially are going to continue to double the number of subsets. And this principle applies to sets of any size. So a set with 4 elements has 16 subsets. A set with 5 elements is going to have 32 subsets. A set with 6 elements has 64, which leads to the fact that I was describing earlier, which is the set with n elements would have 2 to the nth subsets. Now that we can count subsets, we can also count coalitions, which is kind of a nice thing to be able to do. The only difference between coalitions and subsets is that we don't consider the empty set a coalition. So that's kind of the one big difference. The purpose of a coalition is to cast votes, so you need at least one player to have a coalition. So really, to get a coalition, you would just take 2 to the power of n minus 1, and then that would get you the number of coalitions. So again, getting a little ahead of myself there. But yeah, a weighted voting system with n players has 2 to the power of n minus 1 coalitions. Finally, when you're computing critical counts in the Banzhaf power, we're interested in listing just the winning coalitions. So if we assume that there are no dictators, then winning coalitions have to have at least 2 players, and we can therefore rule out all the single player coalitions from our list. So a number of coalitions of 2 or more players can be found with the following. A weighted voting system with n players has 2 to the power of n minus n minus 1 coalitions of 2 or more players. And that's it. Yeah, that's kind of the basics, guys, behind permutations, as well as our coalitions and subsets. Hopefully, you guys enjoyed this chapter. I know I did. Quiz, like I mentioned, is going to be offered on two different equations or 2 different days. First day that it's going to be offered is going to be this Wednesday as planned. Um, the second day it'll be offered will be this Friday. On both days, it'll be offered from 8 a.m. to 4 p.m. So on whichever day you feel most prepared to take the quiz, feel free to do so, and then I can always send feedback to you if you'd like it. That being said, have a good rest of your day, guys, and I'll see you next time.